Hi, my name is Angus.
And I'm Jamie, and this is the Older Garden. So the problem is that organic food is really expensive, and some people simply don't have access to it. Also, people have very limited space, and they aren't able to grow their own food.
So the solution to this problem is the auto garden, and the design is meant for people with limited space. Also, growing food with the auto garden is really cheap and efficient, and the auto garden does not require a large amount of attention because it's self-sufficient.
So the way it works is it uses three components. The first component is the fan. The fan only turns on when the Older Garden gets too hot. This cools down the temperature.
The second component is the heat pad, and the heat pad turns on when the temperature is cold.
The third component is the water pump. The water pump is designed to make sure that the soil in the Older Garden is always moist and never dry. So it uses a moisture sensor, and when the moisture sensor detects that the soil is getting dry, the water pump will send water through the soil.
So for this demonstration, we started with the temperature below the temperature for the fan. So we're heating it up right here, and as you can see, the temperature is rising from the heat pad, and eventually the fan will turn on, like so, and the fan will eventually cool down the greenhouse, and when the moisture sensor detects dryness, the pump turns on, and when it detects moisture, it turns off, and the fan will eventually cool down the project, causing a neutral state.
So a few problems we faced when we were creating this project were, so we had a lot of issues with the temperature sensor, and the temperature sensor needed to be replaced quite a lot because it just kept on overheating and burning out.
A second problem we had was a problem with the current. So the heat pad we have requires a lot of current, and this meant that we had to change our battery a lot. And we used about 3 or 4 different batteries, and eventually we found a 12-volt battery, which was able to power both the heat pad and the rest of the components.
Overall, we overcame our problems and we were able to create an efficient